So today we're going to talk about the universe. By the end of this video, you should be able to tell me the individuals who contributed to our ideas of the universe. You should be able to tell me about the origin of matter and energy and the evidence that exists that supports the Big Bang Theory. So first, we need to talk about how technology has changed our ideas of the universe over time. Before telescopes, we only had our eyes and some measuring instruments, like the one that you can see right here. And so what we thought and what we knew about the universe was not as refined as it was today. But still, the greatest minds of their time had hypotheses about the way they thought the universe was organized and the way it started. So all of the great minds of this time who wanted to know more about the universe had many questions, but we're going to talk specifically about 5 today. They wanted to know about the Earth and its relevance in the universe. Was it the center? What are the stars? What is the universe made of? What are we made of? Is the solar system that we live in at the center of our galaxy? Are there more galaxies than just the one that we are in? And how did the universe begin? And so throughout time, we have tried as a people to answer these questions. The first big question, is the sun at the center? Well, during our time as humans, our idea of this has changed. So Aristotle first said Earth was the center of the universe. He believed that the Earth was at the center and everything else revolved around our Earth. Copernicus, on the other hand, believed in a heliocentric universe or solar system, and he thought that the sun was at the center. So let's talk a little bit more about our understanding of the universe. Aristotle used the tools he had available at the time, not very advanced one, and he believed in geocentric models. So like I said, the Earth was the center, and that the planet and the sun and all celestial bodies, so that means stars as well, traveled in orbits around the Earth. And he believed that these were perfect circular orbits and that everything rotated around the Earth. Copernicus, a little bit later, developed more on that idea, and he, though, believed that there was a sun-centered solar system and that it was called heliocentric, helio meaning sun, centric meaning center, and that planets traveled in the center around the sun. So with improvements to our technology, Galileo was able to observe different things about our solar system and our universe. He was able to observe phases of Venus, and he discovered Jupiter's moons, and he was able to expand on the original Copernicus model, and he once again agreed with Copernicus that our solar system was heliocentric. And Galileo, he kind of had a rough go of it. He was excommunicated from the church. That means he was no longer allowed to be a part of the church, which meant you couldn't be buried with the church. It was a big deal. And he was under house arrest for the last 8 years of his life because the church could not agree with his heliocentric model. They definitely believed in a geocentric or Earth-centered model. Now later on, Kepler was able to further what we know about the universe and our solar system with mathematics. And while all the previous individuals believed that the planets or sun rotated in circular orbits around whether it was the Earth or the sun, depending on the individual, Kepler discovered that in fact these were not circular orbits, but they were ellipses. So that is more like an oval shape, and that was a big discovery in our planetary world. So let's talk about what is the universe and define what that is. When we say the universe, that's everything physical that exists in space and time. It's kind of a big idea, right? Everything physical that exists in space and time. So all space, matter, and energy from the past, now, and in the future. And there is only one universe. Everything ever that has ever existed or could exist exists within the universe which we live in today and which we know today. So let's talk about the beginning. How did our universe start? How did everything that we see and know start at the very beginning? Well, one of the theories is the Big Bang Theory. Now, an important thing to note is that in science, when we say theory, that is a scientifically supported statement that has been supported by so much research, we count it as a law. Now, it's not saying it can't be not supported at some point, right? But this is backed by so much science that it is essentially fact. All right? It's not just, oh, I have a theory that George stole my French toast, right? This is much, much bigger than that. So I want to make sure that we understand that. And the Big Bang Theory says that the universe began as an explosion. And at this explosion, immediately after, it began expanding in all directions. We estimate that the universe that we live in is about 13.8 billion years old, so almost 14 billion years old. And our individual solar system is about 5 billion years old. So, like we said, the Big Bang Theory, there was one single moment. And in that single moment of tremendous violence, the big explosion, all of everything that we ever know was created. Now, the Big Bang Theory, in this theory, we believe that the universe is finite. So there is some sort of end to our universe. Now, we may never get there. We may never be able to comprehend where the ends of the universe are, but the universe is finite. There is an end to it. It's not infinite. So let's talk a little bit about evidence for the Big Bang Theory. So you guys should know that light and other form of energy travel in waves. And because of this, we're able to use these waves to support the Big Bang Theory with some evidence. So one of these is red shifts in galaxies. So you need to know that blue wavelength, this is shorter than our red wavelengths. These are longer. And so we're able to measure these wavelengths that are moving. And this is very, very important to us understanding the way that things are moving in our universe. That's because of the Doppler effect, we can view movement towards and away from us based on light. Now, movement towards us results in a shorter wavelength. Now, remember we said that shorter wavelength was blue wavelength. Movement away from us results in a longer wavelength, or the red wavelength. And so using this Doppler effect of longer and shorter wavelengths and blue and red light, we're able to see the way the universe is moving over time. So let's talk about an example of what that would look like. Here we have an example. If a car is coming towards you, the sound has shorter wavelengths. All right? So here you are standing here. There are shorter wavelengths. They have a higher frequency, and the waves are compressed as it's moving towards you. Now, as it drives away from you, these wavelengths are longer and have a lower frequency. So remember we said small wavelengths are blue in color, and our longer wavelengths are red in color. So if something is moving towards us, we will see blue, or detect blue wavelengths, and if something is moving away from us, we will detect red wavelengths. So kind of as a summary with the Big Bang Theory, galaxies are moving away from us, and this is shown by the red shift, right? Those longer wavelengths, as galaxies are moving away from us, we should detect red wavelengths. That means the universe is expanding constantly because this radiation is moving away from us. And we observe these red wavelengths when we look at the universe through an infrared telescope. And that's how we're able to see and determine that there are red wavelengths, this red shift, and the universes are moving further away from us. Now, blue shift is when universes are moving closer, and shorter wavelengths are blue in color. And if we saw blue shifting universe, that would mean we were experiencing something called the Big Crunch. Now, the Big Crunch is kind of a cool term, but this is the idea that eventually the universe will collapse back in on itself. And we can tell this is not currently happening because, like I said, through those infrared telescopes, we're able to detect those red wavelengths. So blue shift would occur if a Big Crunch was to happen and the galaxies would begin to move closer towards us. Luckily, that is not currently happening at this time. So one of the biggest pieces of evidence for the Big Bang Theory occurred in the mid-1960s when two scientists named Arnzo Penzias and Robert Wilson detected leftover cool-down radiation. Now, what happened was they were doing other research completely different, not related to the Big Bang Theory, and they noticed some interference that was occurring with their tests. And what they ended up discovering was cosmic microwave background radiation. And this was such a huge discovery. And they discovered it with the Holmdel-Horn antenna around 1965 that they won the Nobel Prize. What a big deal this was. And like I said, they found this primordial background radiation, and they discovered that if the Big Bang would have occurred, or did occur, that large amounts of radiation would have been emitted. And that there would be so much radiation that still to this day, 14 billion years later, there would still be evidence of this background radiation. And like I said, in the 1960s, those two physicists who were working on something completely else picked up this background buzzing noise. They actually for a little bit thought it was pigeons that were roosting in their antenna, and they couldn't figure out what it was. And eventually they discovered that it was this background radiation from the Big Bang. So the noise, like I said, turned out to be radiation left over from the Big Bang, and this is called primordial background radiation, or cosmic microwave background radiation. This was a huge, huge deal, and like I said, it won them the Nobel Prize. So if everything's moving apart, that suggests that we were once closer together, right? If there is an origin or one big moment where everything came from, that we at one point were closer together. And so we can assume this idea called the cosmological principle. And there are two parts to this. One is space is homogeneous, and you should 100% know what homogeneous is. We've talked about it when we talked about solutions, right? It means that space is the same throughout. Our window to the universe shows us the same evidence as any other location, and that's how we kind of base our cosmological principles on. The second is that space is isotropic. And this means that space is the same or has similar physical properties throughout the entire space. Right? So we can look in any direction in our universe, and because space is isotropic, we'll see the same evidence for the Big Bang. So we're going to move from the Big Bang now to talking about galaxies. Galaxies, there are many in our universe, and a galaxy is a collection of millions of billions of stars. And there are different types of stars. It's believed there are to be over 100 billion galaxies, so many galaxies, and these galaxies are clustered together and held together by gravity. Milky Way is our galaxy, and the Andromeda Galaxy are in the local group cluster. So the Milky Way galaxy is our galaxy, and we are part of the local group cluster. And in addition to our galaxy and Andromeda, there are about 30 other galaxies in our cluster. So these groups of clusters are called superclusters, and they contain thousands of galaxies and trillions of stars. So here's our Milky Way. It's really beautiful, and our sun, you can see, is pointed right there. It is one of millions of stars in our Milky Way galaxy. So there are mainly three types of galaxies. One is a spiral galaxy. There's a red bulge in the middle, so there's cool old stars in the middle, and spiraling outwards are younger, hotter stars. There's an elliptical galaxy, and these are egg-shaped. They don't have the beautiful arms that the spiral galaxy has, but they are reddish due to older stars. And then we have these things called irregular galaxies, which I think are just stunningly beautiful, and they lack a regular shape. So I want you to think real quickly, what do you think our galaxy is? Is it spiral, is it elliptical, or is it irregular? And hopefully you're thinking to yourself, well gosh, the Milky Way looks a lot like a spiral galaxy, and you would be correct. So hopefully you have learned a lot about the Big Bang Theory in this video and about our types of galaxies.